Hey Advanced Algebra. So today we were working some more on right triangle trig, and the problems we were doing looked like this first example, example 1. So we've got find the 6 trigonometric functions of theta. Notice here that there are 6 of them. Now in class today we talked about SOHCAHTOA, and those are the first 3. So if I write out SOHCAHTOA, that means that I have sine of theta equals opposite over hypotenuse. Cosine of theta, the c, is adjacent over hypotenuse. And TOA, tangent of theta, equals opposite over adjacent. So those are 3 of the 6 trigonometric functions. And then the other 3 are the reciprocal functions. So the reciprocal of sine is cosecant. So you see CSC, that stands for cosecant. And since it's the reciprocal, instead of O over H, it's H over O. You just flip it upside down. The reciprocal of cosine is called secant. Instead of A over H, it's H over A. And the reciprocal of tangent is cotangent. So instead of O over A, it's A over O. So now that I have these guys written out, I need to go over to my triangle and find my opposite, my adjacent, and my hypotenuse. So opposite of my angle theta is my opposite side. Opposite the right angle is my hypotenuse. And my adjacent side I don't have right now, and so I'm going to have to find my adjacent side. Now to do that, I'm going to have to use the Pythagorean theorem. A squared plus b squared equals c squared. And in the Pythagorean theorem, it's really important to make sure that your c is your hypotenuse. So a squared is 5 plus b squared equals c squared, so 14 squared. And now I'm going to square everything, so 25 plus b squared equals, 14 squared is 196. And now to get b by itself, I take 25 away from both sides. 6 minus 5 is 1, so that's 171. And then I'm going to square root both sides to get b by itself, and I get the square root of 171. Now I could turn this into a decimal, but for these problems we're actually going to leave this as an exact value, and so I'm going to leave this as radical 171. Alright, so coming over, I'm now going to fill out my 6 trig functions. So let's see, sine is opposite over hypotenuse. So opposite 5 over hypotenuse 14. So 5 over 14. And since cosecant is a reciprocal, this is 14 over 5. I can just flip it upside down. Cosine is adjacent over hypotenuse, so I switch to adjacent over hypotenuse. And I get, adjacent is square root of 171 over my hypotenuse is 14. So that means this is 14 over 171, root 171. And then tangent is opposite over adjacent, so I take my opposite over my adjacent, 5 over root 171. And cotangent is the reciprocal, so I get root 171 over 5. Okay. Now, one last thing that we have to do on these problems. If it's just a fraction, you can leave it. So this one is done, and this one is done. This guy is finished, and this one. But if you have a radical in the bottom, like tangent and secant, where you have the square root of 171 in the bottom, then to finish the problem, we have to do something called rationalizing the denominator. So right now, I have tangent of theta equals 5 over root 171. And what I need to do is multiply the numerator and the denominator, top and bottom, by root 171. When I do that, the top becomes 5 root 171. And on the bottom, I have something times itself is something squared, so I get root 171 squared. And that's nice because when you square a square root, they cancel out and just leave you with 5 root 171 over 171. And that's your answer for tangent. And then we would need to do the same thing for secant. So I've got 14 over root 171. I multiply by root 171 on top and on bottom. I get 14 times that root on top. Something squared, or something times itself, is something squared, so the roots cancel, and I get 171 here on bottom. So there's my answer for secant. So make sure that if you get a square root on the bottom, that you rationalize. All right, that's it for notes, guys. I will see you tomorrow.